Hi guys, today we're going to talk about Chapter 10, Section 2. This is on measuring angles and arcs. And we're going to talk a little bit about a central angle first. A central angle is basically an angle that's just in the center of the circle. So it's an angle with a vertex in the center of the circle. So you can see right here, you can see that the center of the circle is here. You've got your angle, and that makes up a central angle. It's basically all that a central angle is. So we'll use central angles quite a bit. So if you are confused about what a central angle is, make sure you ask me. All right? The main thing that we need to know about a central angle is that, and we used this really in the last chapter, if we add all the angles of all the central angles up that are in a circle, we get 360 degrees. And you can see by this diagram that is true. And like I said before, we used that concept already in our previous chapter when we had to find the area of a regular polygon. And we used that to find what that angle was at the top of the triangle. So anyway, that should be something that's not necessarily new. All right, we're going to do example 1 here, which basically is an example that you have to find x. Now, since all three of those angles are central angles, if we add them together, which you can see here, if we add them together, you have x plus 90 plus 100, it should equal 360 degrees. When you solve this equation, you get that x is equal to 170. So that's a pretty simple example of trying to find x using central angles. All right, let's talk a little bit about an arc, a minor arc, and a major arc. An arc is a portion of the circle defined by two endpoints. So you can see here that you have, let me just let this play out real quick and then we'll talk about it. We'll talk about everything. All right, so you have an arc which it says a portion, let me just underline this so you know where I'm at. A portion of the circle defined by two endpoints. So this is an arc from A to B, or this is an arc from A to B. So just a portion of the circle. A minor arc would be like arc AB. Okay, this is a minor arc. It's minor because that's the shortest arc containing two endpoints. This is the major arc because it's the longest arc containing those two endpoints. So basically, I put 2 points on the circle. You find which one's the minor arc and which one's the major arc. So that's pretty much it. A semicircle, I think most everybody knows what a semicircle is. The formal definition is endpoints of the arc are on the diameter. So you can see that we still have two endpoints. So you have an endpoint here and an endpoint here. And a semicircle will go between those two. So it's an arc that basically meets the diameter. All right, here's a real-world example that we've got a circle graph or a pie chart here. And this pie chart can really represent anything that you want it to be. It could be candy bar survey that you did and you found out 35% of the people liked Hershey's and 30% of the people liked Reese's and 20% so on and so on. Or it can be any kind of survey. But anyway, we make a pie chart and we want to know what the measure of one of the arcs is. Now let's go ahead and put some letters on this graph so we can talk about the endpoints. Let's call this point A, this point B, this point C, and this point D. And let's say we want to find the measure of arc AD from here to here. All right, so it says find the length of the 35% pie piece. All right, since we know 35% of the circumference is what we want, we're going to use circumference equals pi times the diameter, which in this case is pi times 4. So because if we decide here that the radius is 2, right here you can see the radius of this thing is 2, then we have pi times the diameter, which is 4, which is equal to 12.56. We want 35% of that circumference. So right here you can see we take 0.35 times the circumference to find out how long the arc is. All right, arc, A-R-C, not A-R-K as in Noah's Ark. All right, it's just, so that's 35%. So if I wanted to find out arc DC, then I would do 30% of the circumference and figure out what that equals. If I wanted to find out how long BC was, then I would do 20% of the circle. It's 20% of 5.76. All right, so that's pretty much all that it is to that. That's not too bad. All right, now this is something that should be familiar. It's the arc addition postulate. The arc addition postulate is similar to angle addition, segment addition. Basically all it says is the measure of arc AB, written M with the arc sign AB, this is red, measure of arc AB, plus the measure of arc BC will equal the measure of arc AC. In other words, this arc plus this arc gives you the entire arc. All right, you add the two arcs together to get the total arc. We'll use that in some of the problems in the future. All right, here's an example problem that we need to talk about. It says find each measure in circle F. I really just gave you one of the problems that was in the book. Measure of arc AED is what we want, and that is from here to here. That's going to be that arc. Now one thing that we need to talk about is the arc measure. The arc measure always equals your central angle measure. So the corresponding central angle measure is all you have to look for, and then you know what the measure of the arc is. So I'm looking here, and this angle is 63 degrees, and this one's, oh, moved my picture. Let me fix that. This angle right here is 90 degrees. So that means, let me change colors here. That means that this arc is 63 and this arc is 90. So to find the measure of the entire arc, I'm just going to take 63 plus 90. So that equals 153 degrees. So keep that in mind. The arc measure is equal to the central angle measure all the time. If I tell you that this right here is, say, 110, then I'm telling you this right here is 110 also. They are equal. All right, since this is 90, then this is 90. Since this is 63, then this is 63. Well, and this has got to be 63 also, just because these are vertical angles. So that makes this 63. All right, so hopefully there's no questions about that. If you have any questions, write them down and come ask me about them in class. All right, we're almost done. I just want to let this play out a little bit here. Uh-oh, looks like I forgot that I had written some on there. You can disregard those little writings. because I think that I had changed my mind on that part, so disregard those. All right, moving on. The last one is the arc length. How do you find the length of an arc? Well, I think that most of you kind of remember how to find the length, how to find this area of a sector. This example problem is how do you find the area or the length of an arc? So we're trying to find out how long arc ZY is. So we want to know how long it is from here to here. So again, just like when we were doing area of a sector, we just want part of the circle. Right here is another way to find part. We did percentages on this pi problem just a minute ago. Now we're doing just a fraction of the circle. So we're going to create the fraction. The fraction in this case is 75 out of 360 degrees is the part of the circle that we want. Let's say that the radius here, of course you're going to need to know that. Let's say the radius is 5 units. So to find the circumference, we're going to take 2 times pi, we'll let 3.14 be pi, times the radius. So I multiply this all out, that's going to be the distance from here to here. If I put a piece of string on my circle from here to here, then it would equal, and I'm going to use my calculator here, 75 divided by 360 is equal to 208.3 repeating. And I'm going to multiply that by 2 times 3.14 times 5. That gives me 31.4. Now if I multiply both of those together, I get approximately 654. Oh, I'm sorry, that's 6,541.607. We'll round that to 67. And if I do this maybe say in centimeters, then this is also going to be in centimeters, not centimeters squared. Oops, can't see my decimal point. There's a decimal point right here. All right, so this is in centimeters, not area. We didn't figure area. We figured the length of the arc, the length of that edge piece. Okay, back in the last chapter we did area of a sector. So we did the area of this whole piece before. But disregard that. Let me undo all those. Bloop, 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 bloop. You like those sound effects are good, always. But anyway, that is how to find the arc length. So keep those notes. All right, we'll be using those in class. We're going to be finding area of, or length of arcs quite a bit. And that's it for this time. So you guys have a great day.